Hello everyone, it's Peter here, Pit Fisner. How are you doing, guys? Hello. So, this video is a special one. It's a reply to the video which Robert Murray recorded on his YouTube channel. Let's look at it, please. So it's a 1896, the blowtorch generator. And we can see that Robert is showing a charging circuit with a battery, on-off switch, and a solar panel. And that's a just garden light for about £1.50. If you would check on his YouTube channel, yes, here is his YouTube channel. So that's something which Robert is showing. Now, I would like to go through a few things what he's spoken about. First foremost, for those who don't know, solar panels produce a DC current. DC current has plus and minus, yes. Now, we've got solar panel, okay, this is really fragile thing. We've got a positive and negative, yes, so plus and minus. My meter ended up, because I was tidying up this desk, ended up on the ground. So let's switch to the voltage. Okay, we've got a voltage. You can see here that it's a DC voltage on this side, yes. So whatever it will be shown, it's up to half a volt, but I don't believe will be above. I like this meter, but it's just not the opening only is the downside in it. So let's do positive at the bottom, and at the top let's do minus, and then you will see the difference if I'll do it otherwise. Okay, so we're holding at the bottom probe, positive probe, yes, the red one. In here we've got, oh look, it's a short. It's on the AC. Okay, let's switch to the DC now. Okay, it's 3.335 volt. I don't know if you can see it clearly. Let's maybe open it. Ooh, I'm damaging my tools here while speak. I want you to see it vividly, not just randomly. Okay, so that's positive, that's negative. You see 0.3, if I would take it to the sun, to the window or to the light, yes, it's changing, because that's what it is. And then the opposite way, if I would do it, that's mean the black probe, which is negative, so minus, and this one is positive, you'll see the minus. So the minus means that it's the reverse polarity, yes. Now, when you create a generator, like Robin was showing in his torch, you create an AC. When we're talking about the batteries or solar panels, we've got DC. To convert it, we need a bridge rectifier or at least one diode, at least. Okay, I'll show you here. Yeah, that's the stuff I'm talking about right now. So that's not what I meant to show you. I wanted to show you this one. It's a bridge rectifier under the microscope. Okay, so we've got that's an analog AC current, and that's the positive and that's the negative. So here we insert our 230 volts, let's say, and here comes plus and here comes minus. It's rectifying. I'll show you as well in the regular, no magnification. I just wanted to show you like a closer look. That's the fella, okay, and the cutted side is the plus. The middle ones you've seen, it's a AC coming in, plus is on this side where is the cut, and minus is on this side. So when you've got a generator and you've got those coils which Robert is doing, you need to, if you want to charge the battery with it, you need to use at least one diode or bridge rectifier. Otherwise you're just not gonna do it the right way, and you shouldn't do it. Now there are different kind of diodes. It's worth to know what the Schottky diode is, because it's higher efficiency diode, quicker diode as well. And in certain cases, to not have a big loss, especially when the device not producing a lot of power, you know, you could use Schottky diode, SCHOTTY, Schott, O-N-K before Y, Schottky diode. and that's worth knowing. So yes, so those things you need to keep in mind, amperes and volts in them, yes. And then timing in this case matters. In your case, I mean in the small charging device like the torch, it doesn't matter. Magnets, because you've got a coil and you've got magnets. So where you can get magnets, if you've got an old hard drive, or if you can get from somebody old hard drive, inside them you will find really strong magnets. Of course, in these ones, smaller ones, in these ones, really hard ones. Watch out with these two. You can damage your fingers, literally. I've been there, I've done that, and it's a pain as that's neodymium magnets, and strong, unbelievably strong. You can get these hard drives, faulty hard drives, it's not a problem, for free. Literally, you can get them for free. All you have to do is to look for faulty hard drives. Ask your friends and family for faulty hard drives, old hard drives. Speak to local electronics repair shops, or speak to local IT businesses. Just magnets. You don't need whole hard drive. There is some data on the plate, so you might not want to mess with that one. But magnets are really strong, yes? So worth knowing, because you can get it for free. You don't have to pay, and you can collect whole magnets on a 1 kilowatt, let's say, wind turbine. You really have to take action, because there are 2 magnets in each, yes? Like in this, it's 2 magnets. I don't remember, is it always 2 magnets? Maybe 1 magnet at some of them, and those thinner ones will have 1, and those thicker ones will have 2. But that's for sure, yes. What else we need to talk about? Lithium battery. Okay, many old laptops have 18650s inside. So if you've got a laptop which is dead and you can't use this to do anything else, and you want to have a batteries to play with, you can open the laptop, or you can ask somebody to help you and open it for you if you don't want to risk something, or you don't want to mess things up, or you just don't want to in general do it, because once you will damage thread, for instance, for the screws or something, it might be not reversible, yes. So you can get these inside the laptop, or sometimes the really older laptops have removable batteries, and you can just pry them open, or you can unglue them with alcohol, with petrol. You can unglue them if you can't just open them naturally by prying, but you can get them, yes, you can get them. Watch out when you're opening it to not push through knife or screwdriver. Don't poke them for any reason, no. One of these batteries, it's 3.7 volt. You can charge up to 2 volts, depends, some of them for free, but 2 usually. And then they are holding 3.7 volts, 3.7 something, yes. These are in the parallel, so they will have, again, similar voltage. What they have, 4.2, so these are charged, yes, these are charged batteries, yes, 4.210. So that's what it is. And again, magnets for free, batteries for free, yes, you don't have to pay for them. If you really look carefully, ask again some IT companies, some electronics repair shops, you can get it. Charge protector charger. Okay, so these ones, there are 2 types of converters: DC to DC, back and boost converters. Okay, so let's talk about it. This is a boost converter, like actually 1, 2, 3, 5 of them, yes. And that's, you see, up, so that's so that I will know. I've printed out, because I just don't want to forget, with MT3608 chip. And there are back converters as well. I've got here one, that's a back converter, okay. These are only up to 3 amps. This is a 3 amp one, but there are as well, oh, here I've prepared, this is a 500 watt one, okay, that's a buck converter. So if you need a voltage for the LED, for instance, and you will charge with your solar panel, that you can put it through the buck converter, okay. So if you've got more voltage from the, let's say, from the solar panel, you can get cheap solar panels everywhere. or you can get them in some old toys or old stuff, yes. Only in the calculators, those are too small current over there, it's not worth. And then buck converter, I've got only in and out, and you've got a potentiometer, small potentiometer to adjust the voltage. The same here, you've got small potentiometer, you've got in and out. Just check polarity, which one is a plus, which one is a minus, and you're good. I'll show you both as well under the scope so that you will have a better look. Where is my camera here? Okay, these are really cheap, by the way, really cheap. Let us put some light on, or no need for a light? No need for a light, it's good enough. So yeah, you've got this one has a VIN, voltage in minus, and voltage in plus. Plus, we've got a micro USB as well on top of that, yes. Then you've got this potentiometer to adjust what you need as a voltage, and you've got the out to control the voltage on the output. That's C, capacitor doesn't matter, that's diode. You can learn how these components are looking here. That's a coil, and that's that's IC, yes, small IC as a driver. A resistor 222 and capacitor as well, yes, and all of them are the same. You can see how it's looking. And then you've got this, that was a boost converter, and that's a buck converter. Here it's in minus, voltage in minus, yes, capacitor. Then you've got this chip the other way around. Oh, JM21RP. Oh, here it is, LM2596S. 2596S, yes. So this one is with a control. That's like a MOSFET with a control. You can Google what this means. Again, another diode. Here we see a resistor, capacitor below it. Another aluminum capacitor, that's a regular SMD capacitor, I think, or 402 size from what I see. Quite big one, or 0603. This is quite big one. So that's what it is, guys. With a buck converter, again, you can lower the voltage what you have, and when you need to increase the voltage, yes, you use boost converter, but there are minimums which they are operating, so you need to have a minimum of something, yes, or maximum of something. So just keep in mind, but they are really cheap, you know, we're talking like £1 to £2 on AliExpress for that module. You can get them on eBay as well, or Amazon. You'll just pay a bit more, of course, but it's not a dear toy. This one is dear because that costs over £10, but that's up to 400 watts. You can permanently take 200 watts through it, no problem, and that has quite high efficiency. They've got quite efficiency as well, high efficiency. So those things which it's worth to know when you're dealing with electronics: buck converters, boost converters, DC to DC converter, yes, up or down, and LED. Okay, so LEDs, where you can get when you can get LEDs, you might be asking. Well, this is a good question, and you can buy them really cheap, to be true. You don't have to get them from somewhere, but you can get them. You can get really bright LEDs. I'm talking at least 50-60 lumens, sometimes 100 lumens in the backlight of the telly. If you're gonna speak again with electronics repair shop, TV repair shop, or get the cracked screen TV telly for free, you can open it and get LEDs in the backlight over there. So then that LED, if it's there are two type of strips in two technologies nowadays which are common, you can say. Full backlight is going more into becoming a vintage one, but there is an edge backlight. Okay, so I'll pause and I'll bring something to show you. Okay, we will go under the scope, but I wanted to show you first like that. So this is a strip, and this is a you see those diodes, how they are, let's say roughly here on this, yes, and that's edge backlight, and that's full backlight. They've got a glasses usually. So let's go underneath the scope. I've made another mess to tidy up. So look guys, this is an LED, and as well it has its own plus and minus here, yes, coming in, and they are in series, connected in series, and they are dying really quickly, 3 to 5 years, just because, well, the depend which ones. Yes, the full backlight, it's tend to get longer, like 5 to 10 years. That was the full backlight, and that's edge backlight. Okay, you see those spots, like a black spot on this one and on this one, but you can see that this is a bit darker. This is a bit darker, but okay, these ones don't have those spots. I don't see those spots, so these are looking good. Yes, if we would apply voltage, they would probably most likely work, and there will be only one in 2 strips, will be one faulty, but I don't leave them for the customer. I don't see any damage here. So what's happening is, why they are failing, I'll tell you, so you will know as well. When you've got a diode which has some milliamps, and then they are going in series and they are passing the whole amperage through itself for all of them, then they will die quicker. As well, when they are efficient in 100%, they will die quicker. So what you could do is you could do them in the smaller segments or connect them in parallel, and instead of doing 2 of them per TV, yes, like 50-inch, you could do 4 of them. That would be already, because at the top you could put another ones, and then make less brighter, yes, and then have higher efficiency diodes, yes, and dim them to have less, and then they would last longer than the telly would last, yes, if they would not transfer so many amperes. But that's why they are dying, and that's why you can get them for free from old telly, or with a cracked screen telly. Yes, so those are the 2 tellies which you can find for free, and you can get that bridge rectifier, by the way, it's in the power supply from the telly, yes, from the TV as well. So you see, you can get it for free, literally. And then on-off switch, well, on-off switch is in so many toys, so I don't have to tell you that, yes. So you see how many spares you can get for free, literally. It's impossible to not get them for free, literally, yes. So many electronics thrown away, that if you want to learn it, or you want to do some projects like Robert is showing in his channel, it's really doable, guys. It's just a matter of willingness to do it. Yes, I'm fixing on a daily basis. If I would tell you how my day was, you wouldn't probably believe me, but I've done 4 devices today already. It's 7 p.m. from scratch to the end, or ordered parts for 1, and the rest is done, yes, and 5th is started and will be done. I'm fixing all household electronics, yes. I've got small solar panel over there, that's 25 watts, you can see on this YouTube channel, and I've got almost 1 kilowatt in regular solar panels, which I received for free from one of my customers, yes. So I'm doing all project in the playlist inverters about it. But anyways, that's it, that's everything. So you see, you can get these things for free. Just you need to start learning about them. Here is a playlist as well on this YouTube channel about learning basics of the electronics, yes. So it's worth watching, so you can understand what to learn, how to learn. And yeah, you can learn on your own as well. There are many YouTube channels more professional than my one. I'm just recording what I think it can be useful for the viewer. But that's it, guys, that's everything. Sorry that it took me 19 minutes, but I couldn't explain so much in such short time. So thank you for watching. See you in the next one. Bye bye.